In this tutorial, we are going to cover collisions. This is going to be a two-parter. In this part, we are going to just cover what are collisions, what are they used for, and we're going to look at one of those uses that doesn't involve programming, and that is physics. In the next tutorial, we are going to look at how we can use collisions and run our code through it. So when something collides with something else, we might want to run some code. We're going to look at that. And finally, we're going to use all that collision knowledge that we've built up to build a respawn area for our players. So when our player maybe falls down a gap, or they might fall into a pit of fire, we want them to respawn somewhere. So when our player collides with this death zone per se, we're just going to respawn them back into a position. That requires collision and requires us to run some code when we collide with it. And we'll look at that after we have covered the basics of collision. So what are collisions really? All collisions is a mesh with no rendering. A collision is just a mesh, just like any other static mesh, except we do not render anything on the mesh. Unreal has three basic types of colliders. It has a capsule shape. We saw this specifically in our player character. When we made our player character blueprint, it came with a capsule collider. So traditionally, characters use a capsule collision because it's a fairly simple shape, so it's not too heavy on calculations, but that capsule shape best describes a person as opposed to the other two types that Unreal has, which is a circle or a sphere and a cube. These two don't really fit over a human as well as a capsule, so we use a capsule for our characters. Generally, most other things, as much as we can try, we try to use a cube. We could also, just import any mesh from Maya or Blender and set it as a collider. It is ideal when working with collisions to use the simplest shape possible. So as much as we can, we use these three Unreal primitives for our collisions. We will also just shortly look at a tool that Unreal has to let us just create collisions based on the shape of objects to give us slightly more accurate collisions. So what are the main uses of colliders? There's really three major use cases for colliders and why we use them. One is physics. So when we thought about, a box and the box is falling down, when we simulate physics on it, we see the box as mesh falling down, but really what is actually acting on this physics is the box's collision. So when the box touches another box, it may tumble, it may, spin and fall further. All of that, we visually see it on the mesh, but really it is the collider of that box or whatever mesh we're using that is doing this physics calculation. We'll see this shortly in this video. The next use is overlap events or triggers. And all this is if we have a collider and we have another collider and they intersect with each other, that is going to either that's going to fire an overlap event. In Unreal, we call them overlap events. In Unity, we call them triggers. But all that is when two colliders intersect with each other, it is going to let us run some code. This is how we're going to do the respawning. So, when the player collides with the death zone, we are going to run some code that says move the player back to wherever we want to respawn them. And the final use case of collisions is raycasting. So if we think about what a ray is, it's just a straight line. Raycasting is really just that. It is firing an invisible line in some direction. When that invisible line hits a collider, it will run some code, and it would also gives us some information. What collider did it hit? Where did it hit the collider? So on and so forth. This is something we're going to look at in our second project when we make our top-down shooter game, and we want our character to shoot. When they shoot, what we're really going to do is just raycast. And if our array hits an enemy, we know that we hit an enemy, and so we can like tell the enemy, take damage, or maybe they die. Again, we'll get to that later, but good to know. The three main uses of collisions, really in any game engine, is physics, overlaps, and raycasting. Let's move on to the engine, and let us just see the physics in action in this video. So here in Unreal, I have a new level, and I'm going to be working on this BP test blueprint that I have made, and it's using SM drone. I've been using this drone so far in all the tutorials I've made, so I'm just going to continue using that. Let's open up the blueprint and go to the viewport. So here I have my SM drone, and I wanted to simulate physics now. When I come down here and try to check simulate physics, it's grayed out, doesn't let me do anything. This is because SM drone does not have a collider associated with it. So we cannot simulate physics on something that doesn't have a collision, because like I said, physics is simulated on those colliders. It's not simulated on the mesh. The mesh is just what we visually see. So simple fix for this, I'm going to come here, I'm going to add a collision. We can add any of the three simple collisions that we talked about Unreal having. I'm just going to add a box collision for this. I'm going to make the box collision the parent, and so the SM drone is a child. And now you can see that my box collision has simulate physics, and it's not grayed out anymore. I can actually check it. So let's just check it. Let's save, come out here. Let's drag our drone, set it up top, so it should fall now that I'm simulating physics. And great, it falls, but it also just went through the floor. When I hit stop playing, Unreal nags me with this little error. It says the box is set to simulate physics, but collision enabled is incompatible. So let's take a look at that. Let's come back to this box. And physics is simulated, that's perfect. But here in collision, we can see the collision preset is overlap all dynamic. So when we think about our uses, overlap or trigger is when boxes intersect. So this setting is just saying that this box isn't going to collide with things, or it's not going to block things. It is just going to overlap with them, which is why it went straight through the floor, because the preset isn't to block, it is to just overlap with things. That's just intersect with them. So if we click here, we can see block all dynamic. We can select either block all dynamic or physics actor. Both will work fine. I'm just going to select block all dynamic. And now when I run it, you can see it falls, but it bounces when it hits the floor, because now we've set that collision. We're telling Unreal this isn't just for overlapping. We want it to block whatever it's hitting. One nice thing is under box, I was talking about how our colliders aren't visible. When we run this game, I cannot see my collision anymore. But for debugging purposes, Unreal lets us visualize the colliders. All we have to do is, with the box component selected, search hidden. And you can see under rendering, hidden in game is checked. When you guys make your games, you want to leave this checked on. We don't want to see our collisions. But for testing, now when I run it, you can see, I can see my collision box around here. So just to show you guys, it is really the box that we're colliding with and not the mesh. I'm going to drag out a cube. Make sure to place it under the drone. And when we simulate, we can actually just grab our drone and move it ever so slightly. And you can see the drone isn't falling over, even though like its little tip is touching here. When I move it past halfway, just like a box fall, it falls. And when it comes to rest, you can see it is as a flat box is where it's coming to rest. So it's really the box that's running this collision. When we do simulation, or really any collision work, we do want to, as much as we can, use simple collisions like this box. But in this case, this just doesn't feel right. This box doesn't accurately represent this drone's collision. And Unreal has a few tools to help us solve that. So I'm just going to come back here into BP test. Let's make the drone the root object again. Let's just delete this collider. So again, here when I go down, simulate physics does not let me use it because there's no collider anymore. Let's come back here, and I'm going to open the static mesh object. Just double click it. This opens Unreal Static Mesh Viewer. We can see there's my drone. We can look around it. And we could also, if we wanted to here, we can associate it with a texture. This drone isn't UV'd, so whatever texture I give is just going to look weird. But it doesn't really matter. So right now there is no collision on this drone. We can add a collider to this drone by just coming up here, clicking collision. We can see that we can add a sphere to it, a capsule to it, a box to it. But if we wanted to do these, I would have just done it in Blueprint, in the actor like we just showed. Instead, let's look at these options here. Add 10 DOP, 10 DOP. We have 18 DOP and 26 DOP. I believe DOP stands for decomposition of primitives. That's unimportant to us, but really knowing what this does is important. And all it really does is it will make a shape. You can see here it's made a collection of very simple polygons that kind of estimate the shape of our object. We can always click on it and delete it if we want, and 10 DOP will use the least amount of primitives to try and make it. So it's still more accurate than a cube, but it's kind of chunky, not super accurate. All the way down to 26 DOP, which makes it even more accurate. You can see this really encompasses the object. It's still not the meshish shape, it's still an approximation. But when it comes to physics, this is a good trade-off to make. This is going to be more resource heavy than just the box, but maybe we only have one drone in our game, maybe we only have 10. So using something like this would be good, because it will give us a more accurate representation of this mesh in our physics. So let's just see that in action. I'm going to make sure to save this drone. Come back to BP test. Now we can see simulate physics is not grayed out anymore. It's actually going to let me do it. So let's simulate physics. Under here, this collision preset's already set to physics actor, which is great. Check this, and let's see this one in action. Unfortunately here, we can't visualize our collision anymore. You can see hidden in game is unchecked. If I was to check hidden in game, our entire mesh would disappear. So when using these built-in or these generated collisions, unfortunately we cannot visualize it while playing the game, but we can still see it in action. I'm just going to play and focus in. You can see it was already bouncing around, which looked a little nicer. And let's just move it. And again, we can see that it bounced around and it landed much more accurately rather than just as a box. We can lift it up, we can even rotate it and see. Our box would never be able to lay down at this angle. Our box could only lay down on its 6 flat surfaces. So this way we know that now with a more accurate collider, we can have our physics look nicer. It doesn't quite look as chunky. This is a trade-off, so we don't want to be using this everywhere in our game. Modern computers are very powerful, so we can use it a fair amount of times. But it's just good to know again that as we're doing this, it is a trade-off. The calculations become more complex, but our physics also looks better. So one last thing I just want to show you guys. Let me delete this. And now if you go back here and I look at physics, it's checked to true, but it's grayed out because there is no collider anymore. If I were to run this, if I was to run this, Unreal will let me do it, but this actor is just going to fall down. And so it's not going to work. We need to add a collider to it. We could do it back here again, but just good to know again. It can default to true, or if it was true and then we lost our collider, it's not going to let us turn it off. Kind of annoying, but easy enough to deal with. Just add a collider and turn it off. The last option I really wanted to look at is under collision complexity. It defaults to project default. And there's two types of collisions Unreal lets us use. One is a simple collision, one is a complex collision. A simple collision is what we've been looking at, the cubes, the capsules, all of these generated collisions. And simple collisions are used for physics. Very specifically, simple collisions are used for physics. Complex collisions are used for our raycasting. They can be used for our triggers. But the primary purpose of a complex collision is when a physics object collides with a complex collision. So the complex collision won't have its own physics, but when a physics object collides with it, then it'll act, and it will, the physics object will collide with that complex collision. This is something you see often with terrain, for example. We want our terrain to look as nice as it can, and same thing with the physics. So our terrain will have complex collision. The terrain itself won't have physics. It's not going to be falling or rolling or bouncing. But when something hits the terrain, it's going to use its complex collision to calculate its bouncing, its rolling, its falling. So let's just look at this again. I'm going to take this project default and change it to use complex collision as simple. So we're telling it to take its complex collision and let's use it as a simple collision. When I do this, we can see that we literally get a collider that looks like the mesh itself. And this, we can't use this for physics. We can see that by, again, simulate physics. It lets us turn it on and off. But if I was to hit play here, nothing happens. And when I hit stop, Unreal yells at me saying that we're trying to simulate physics, but whatever asset has complex as simple collisions. So we cannot use complex as simple collisions and simulate physics. But what it's really used for, and we can just turn this physics off and just take a quick look. I'm going to scale this drone up a little bit. Delete this. And let's drag a sphere out. I'm not sure why that sphere rotated. But let's drag the sphere out and let me scale it down just a tad bit. Make sure that it's over our drone. And I'm going to simulate physics on this ball. Make sure that its collision is also a physics actor. Let's simulate this. And you could see it's a little hard because it's quick, but we could see that it rolled off of that very nicely. So let's take another look at that real quick. This time I'm going to hit simulate and immediately hit this pause button here. And what that does is it pauses the simulation. Let's move closer. And let's use this button right here that says advance a single frame. It's just going to calculate one frame at a time. And now we can see the ball hits, very nicely comes in contact with here, and it just slides right off. So we are using this mesh as a collider to calculate physics changes in the ball. That's really the reason we use complex as simple. We're not going to use it for our own player. It's mostly meant for like terrain and stuff. Good to know it's there. If you think sometimes when our mesh comes in, this could for some reason be turned on, and you might get that warning when you try to turn physics on. So it's just good to know this option's here. When you guys are making terrain, if you import it from Maya or 3ds Max, or I'm sorry, Maya or Blender, you want to come here, use complex as simple. So that has been the basics of collisions, how we can manipulate it, how we can create collisions on our mesh, and how we can also, in our actor, simulate physics and, put it in the world and see it working. In the next video, we will cover collision events. Thank you for watching.